Okay, these are questions 21, 22, 23, 24, 25 from the test 2 review. So this first question, number 21, says rewrite each equation as requested. Rewrite is a logarithmic equation. So there are three parts to these. There is what we call the base, and most of you could figure out that the base is 6. There's the exponent, and then I'm just going to call this one the other guy. So it's helpful to memorize how these go when you're translating from an exponential equation to a logarithmic equation. So for a logarithmic equation, you want to write log for your log. The base is always down in the subscript. So if my base is 6, then I'm going to put that in the subscript. My exponent is always the answer I get when I'm taking a log. So when you take a log, you're getting the exponent as your answer. And then the other guy would go in the only position that's left. So that's how it would look. All right, B says rewrite as an exponential. So we're simply going the other way. So if I'm given a logarithmic, so I have a log base 4 of 1 over 64 equals negative 3. I would write it as, here's my base, 4 to the, that's always the power, negative 3 equals 1 over 64. And that's how you would write it. Question 22. Is the same type of deal. It says rewrite each equation as requested. So rewrite as an exponential. So I've got ln of x equals 3. So an exponential always starts with the base and its power. And here you don't see the base, but ln is a natural log and the base is e. So this is going to be e to the third power equals x. So it kind of goes like a little circle like that. All right, and then I've got this one, e to the 7th equals y. They want me to rewrite it as a logarithm. So remember, you would always put log to start with. Your base in this case is e, but then you should realize the log base e, we actually have a shorthand version, which is ln. So that's log base e. Remember, the log always gives you the exponent as the answer, so the other guy would go there. All right, 23, they want us to evaluate these expressions, and they're not really ones that you would want to put in your calculator. So I'm gonna show you how to do it by hand. And usually, if you just convert it, then it makes better sense. So this first one, I have log base 5 of 25 equals something. I don't know what it equals. That's what they want me to tell them. So almost every time, if it doesn't make sense to me, I can convert it to the other format and then it will make sense. So I could go 5 as my base to the x power equals 25. Now, many of you could guess that. 5 to what power is 25? Well, 5 squared, right? So this is 5 to the 2 equals 25. If you weren't sure, there is a technique. You can reduce this down. So you could go, well, let me break 25 down. Oh, 25 is 5 times 5. I'm going to break it into its prime factorization. So that's 5 squared. And once you have the bases equivalent, then you can just set those exponents equal to each other and you'll figure out what x is. So the answer to that is 2. 5 to the 2 power is 25. All right, let's look at this one. This one's a little bit harder. So log base 2 of 1 over 32 equals something. So I'm going to convert it. 2 to the x equals 1 over 32. Well, that one's a little harder to guess. Some of you could guess it, but it's a little harder. So what I'm going to do is I'm going to factor this 32. I want to get it into 2s. So it's 2 times 16, 2 times 8, 2 times 4, 2 times 2. Hope you can see all that. Yeah. So its prime factorization would be 1, 2, 3, 4, 5 2s. So I could rewrite it as 2 to the x equals 1 over 2 to the 5th. Now, hopefully you remember that if I want this 2 to the 5th to be up here, all I gotta do is change the sign of the exponent. So 2 to the x equals 2 to the negative 5th, and that moves it moves this up to the top. And now my bases are identical, and I could just set the exponents equal to each other, so x is negative 5. So my answer is log base 2 of 1 over 32 equals negative 5, because 2 to the negative 5th power gives me 1 over 32. So that kind of had a lot of little rules all in one problem, which can definitely make it more difficult because you have to remember all those little things that you did many months ago, maybe even years ago. All right, let's look at number 24. It says, use the properties of logarithms to expand this, log of x to the 7th times y. Okay, so the properties of logarithms, there are 3 properties, and one of them says that if you have a product, in other words, if what's inside your log is being times, you can split it into 2 logs and connect it with a plus. And the reason is because logs are related to exponents. So it's kind of like, remember when you multiply bases, you add the exponents. So this multiplication converts to addition with the 2 logs. Okay, another property of logarithms is that if you have an exponent, you can pull it out in front of the log as a base. So I can pull it down as a 7 log x plus log y. So this is the expansion, and that would be the answer. Each logarithm should involve only one variable, so this only has an x, that only has a y, and should not have any exponents. So I move my exponent out front. Assume that all variables are positive. So the last question for this video is number 25. It says write the expression as a single logarithm. So what we're doing is the opposite of what we did here. We're starting with something that's expanded and we're going to bring it back to something that's condensed to a single logarithm. So, and this is actually kind of a hard example, I think, compared to some of the other problems that they gave. So I have 2 log base m of x plus 4 times log base m of z minus 5 times log base m of y. So that's the problem. All right, so this one isn't so bad. I'm going to reinsert my number out front up into the exponent. So I'm going to have log base m of x squared. And now I want to get rid of those parentheses, so I'm going to distribute my 4. So 4 times this is just 4 log base m of z, and 4 times the other one would be minus 20 log base m of y. Okay, just like I did on the first one, I'm going to take these leading numbers and put them up in the exponents like that. So my next sentence will be log base m of x squared plus log base m of z to the 4th power minus log base m of y to the 20th power. All right, so I'm almost done. Remember, the plus allows me to multiply, and then the minus is the opposite, so it allows me to divide. So if I'm going to write this as a single logarithm, I'm just going to have a single log base m. The x squared gets multiplied by the z to the 4th, and then the y to the 20 is divided because of the subtraction sign. All right, so that's it for that. I'll see you next video.